Okay, hello all. So this is going to be a quick and dirty video on one of the revision questions for this analysis task on polynomials, the one that you asked me about in class. So it is this one, question 3. A rectangle is inscribed under the parabola given by this rule, so that two of its corners lie on the parabola and the other two lie along the x-axis at equal distances, and this will be key in a second, okay, that they're equal distances from the intercepts the parabola makes with the x-axis. Calculate the x-intercepts of the parabola. Well, the x-intercepts are x-intercepts there, and either, okay, right there. It's pretty obvious looking at this that one's 0, but we want to make sure. Doing these problems, I'm going to be showing you two ways to do it, one by hand and then one by CAS calculator, because it's CAS active. Sometimes, even though the CAS is there, it's not always the quickest, because once you type everything in, it would have been quicker to do it by pen and paper. This side, some pen. Right here, so x-intercepts. Alright, x-intercepts, we know y is 0. Handwriting. So we get 0 equals rule. So we can get x minus 3 squared equals 9. So we get x minus 3 is equal to plus or minus 3, because I've taken the square root of both sides. So x is equal to plus or minus 3 plus 3. So x is equal to 0 or 6. That's pretty quick. Now, if we want to do the CAS calculator, what would we do? Well, we would be using this bit here and give us that. How do we do that? And another thing, first thing I'm going to do is I'm going to go menu, actions. I'm going to clear my A to Z's. Okay, I'm going to clear out my variables, and then I'm going to clear my history. Good thing when you're coming into something fresh, it means there's nothing retained that's going to mess up somehow. Right, so let's go menu, algebra. Okay, and we are going to solve 0 equals equation was 9 minus bracket 3 minus x all squared. Okay, and if we do this now, we're going to throw an error. We need to tell the computer what we're solving for. So comma x, we want to solve for x. Hit enter. X equals 0 or x equals 6. That works fine. Ooh. Let me get out of my pen. Okay, so that's part A. Calculate the x-intercepts. Express the length and width of the rectangle in terms of x. Okay, this is something that is pretty much purely pen and paper. Part A, part B. So let's have a look at our image. Length and width. I'm going to call here the length, and I'm going to call this side. Ooh, that's not a W. I'm going to call a height, really. I'm going to call that width of my rectangle, length across here. Now, the width is really easy. It's that bit there, okay? And we're told how long that is. That's our y value, and we're told in terms of x. So width is easy. Width is equal to 9 minus the square root of x minus 3 minus x all squared. That's easy. Now length is a little bit harder. What is this value here? in terms of x. And it comes down to figuring this out is knowing this whole, it's at equal distances from the intercepts. We know that's 0. That's what we found out. And we know this one is 6. So Al, we've got this midsection in here. I'm going to work you through this mentally, how I went about it. And I'm going to copy this so we can look at it a couple times. Okay, so step 1 in this mental process is, well, I need to, if I've got L and I know this whole length is 6, my first step of my mental thought was I know that this bit here is 6 minus our x value, because right there, that's x, according to this, and that's our x value. So right there, and that's my first mental thought. That bit there is 6 minus x, little length. There, 6 minus x. Mental step 2. Mental step 2 is that that bit there and that bit there are the same. Mental step 3. Put it here. Okay. Means this bit here. Go back to my blue. And some of you would have already seen where this is going. This bit here, our blue section, is equal to 6. That one there and that one. Okay. And those two combined is 2 6 minus x. There's that side there 6 minus x, so those combined is 2 times 6 minus x. So our blue section, we've said, is our length. So we can go back up here. Length is equal to 6 minus 2 6 minus x, and if we want to expand that, we get minus 12 plus 2x. Get length is equal to 2x minus 6. Gives us our length and our width in terms of x, which the question asks for. Hence show that the area, so part C now, hence show that the area of the rectangle is given by a equals 2x cubed plus 18x squared minus 36. And you'll notice in this section, actually, I haven't touched the CAS. There's no use of CAS. In the next bit, though, it is really handy. This is where it is more efficient. Let's do part C. Area of any rectangle is equal to length times width. So we get 9 3 minus x squared all times by 2x minus 6. This is just a binomial expansion. Okay, one term, one term, one term, one term. We can use our distributive law. And I'll go through this quickly, working out. We're going to get negative 54 is my outside minus 2x minus x squared is my inside. My first bit is going to be plus 18x, and my end bit plus 6 minus x squared minus 54 2x 2 9 minus x plus x squared plus 18x plus 6, and then the same brackets. And that's just the expansion of that. So that's the expansion of that. So we get negative 54 minus b minus 18x plus 12x squared minus 2x cubed plus 18x plus 54 minus 36x plus 6x squared. This gives us, we can do a bit of cancelling. We have a minus 54, a plus 54. We have a minus 18x, a plus 18x. Get negative 2x cubed plus 18x squared from that one, and then minus 36x. And let's check the problem if that's what we're after. Yes, it was. That's what we're after. Okay. And that took a minute or two. There is a way to do that with CAS. This one, not using the solve, what we're going to do is menu, algebra. We're going to expand because we had a whole bunch of brackets in there. We're going to expand that whole expression. So you pretty much just type the whole thing in your calculator. So you're going to be typing this start expression in. We're going to expand that, and that'll hopefully give us the exact same answer. So let's try that. So expand, we had brackets 9 minus x minus 3 all squared, close bracket, times by bracket 2x minus 6, close bracket, close that bracket, any, enter. Oh, look at that, gave us the answer. Much quicker. As active, you're more than welcome to do that. I'd probably type this as you're working. You would have, if you're doing CAS, you'd have that, 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 and that. That would be your working out. So that's part C. We've got it in that terms. For what values of x is this a valid model of the area? Well, we can look at our picture intuitively and think, well, what can my x's be up to? Well, it can be up to 6. Could go all the way across and that would work fine. It couldn't include 6 because that means we'd have a length of 6 but a height of 0, or a width of 0 I should say. So it can't be up to. And going back the other way for our current expression, could we have an x of 0? Is that sort of switching this side and this side? Best way to check this would be graph. So let's go to a graph. And we got that expression. So what you can do on your CAS, you can see over here at the side, go down here, press up, that highlights that. Go dot, actually sorry, out of that. You just go up to it, highlight it all, hit enter, that copies it down. Go back to the start. And I'm hoping you're knowing where we're going with this because this is our area formula. We're probably going to be doing a bunch of stuff with this question, not too much. But like I've said, in the analysis we will. So what are we going to do? We're going to define it so it makes it easier to use. Menu, algebra. Action, define. We're going to just call this a function, or maybe a of x for area is equal to that. Done. That means we can go to our graph and just type a of x straight in, hit enter, and there we go. Now, go there was another thing that we can do. We know we definitely can't have an x less than 0, and we can't have an x greater than 6. So what we can go, get my equation back up. What was the thing that I talked about today in class? Control equals sign, and we can set our domain, our allowable x values. We know it's likely going to be just to be completely inclusive, 6. There we go. That's restricted it. That's much better. Go zoom it. There we go. Okay. This is where now mathematically and then an intuitive interpretation of our graph. Here we have an x of 3. Let's go back to our graph. Okay. This is telling us if we put an x of 3 in, we're going to get an area of 0. What does that look like? Okay. That means my x, okay, if I chose an x of 0, that means I have one line here, and then this side is also there. They're straight on top of each other. That means it's not possible. Okay. So what values of x is this a valid model of the area? We would say part D, okay, x is greater than 3 or less than 6. You could get into an argument here and say this is still technically a valid model if, okay, let's think of it, let's take x instead of, this is our halfway, let's take it over this side. Well, if that's our x point, well, our other side then will be the same distance from the other intercept, so it would be over here. So we pretty much just reversed our sides. The problem with our equation, okay, that we generated for area, it's going to give us, if we consider our x in this side of the graph, this side of 3, it's going to give us a negative area. We could intuitively think though, well, no, we know the area is not going to be negative, it's just the way our equation is eventually being generated. So I would be happy with this. I'd be even happier though you said x was intersection, right? X is not equal to 3 intersection with 3. Okay, so it can be anywhere from 0 to 6, not including 3. That's part D. And calculate the values of x for which area is equal to 16. So we would use our equation. If you're doing a pen and paper, you'd go 16 equals negative 2x cubed plus 18x squared minus 36x. So 0 is equal to x minus 16. Okay, a cubic with a constant of 16 and it has a coefficient in the front of the x cubed term. That means it could be an absolute pain to use the null factor law to try and find your first factor. Once you had your first factor, you could use long division, get your quadratic, and then factorize your quadratic, probably by inspection or the cross method. I'm not going to go through all the time to do that because that would be insane to do it in a tech active test or analysis task. So we go back to here. We've defined this of a of x. So we're going to menu, algebra, solve when a of x equal to 16. Just like I said, our area is equal to 16. I'm going to solve for x when that occurs. Hit enter. Okay. and that gives us this value. If we want to go up and get an idea of what these values actually look like, Control Enter gives us some decimal places. So x is equal to negative 0.37. We know that value is not possible. Okay, we can't have a negative x value. We go back to our picture, that would be over here somewhere. Not possible. Okay, or x equals 5.37224. So that's that question done. Hope that helps. Stick a question on Google Classroom if you still need help.